Okay, at the end of class on Friday, we were doing example 2, which was a hanging sign problem, and it was on this sheet, center of mass, with a couple of examples. And so before we do question number 33 from homework, I just want to go back to this question because question 33 is identical to it. So we were almost finished. So we had the hanging sign. The sign was out on the end of a beam. The beam was uniform. It was 4 meters long. There was a guideline, a wire that was attached to the house, and it was asking for the tension in that wire. And so we picked our pivot point here where the house was the beam was attached to the house, and so the torque from that one went to 0. Tension would be positive, these two would be negative. The theta of the beam and the sine both went to 0, but the one for tension didn't, and it was given that that angle there was 30. So then we fill in our, and I think we had done this, I just thought I'd backtrack a little. So the R of the beam, it's a 4 meter long uniform beam, which means the R of the beam is 2 meters. Mass of the beam, it told us, was 3 kilograms times 9.81 meters per second squared. The sine is all the way out on the end of the beam, so it's going to be 4 meters. The sine is 9 kilograms, 9.81 meters per second squared. The R for tension, the wire's connected all the way out on the end, so it's 4 meters. And then the angle is between the R, which is the beam, and the F. So it's 30 degrees. So you put sine 30 in here. And then you punch all this in, and you should get F tension to be 206.01 newtons. And really, that's all that the question asked. But there's a second part to it that I didn't write down there. And part B would be, what's the F of the house? That the F of the house that the house is putting on the beam. And the easiest way to do this is to do sum of the torques. First in the x direction, and it should be 0. So in the x direction, tension's going to have an x component. So F tension x. And the F of the house is going to have an x component. And so it doesn't really matter which one you call positive and which one you call negative, because they're just going to be equal to each other. So F of the house is going to equal F tension x, which will be F of tension, and the x component is the cosine. So cos theta. And so you can find this. You could do 206.01 newtons cos of 30. Or you could wait, perhaps, and you could go and you could do sum of the forces in the y direction. Also have to be equal to 0. So in the y direction, I'm pretty sure the F of the house is going to be going up. I know the F of the tension is going up. So it'll be F of the house y plus F of tension y. And then the other two, the Fg of the beam and Fg of the sine, are both going down. So Fg of the beam minus Fg of the sine has to equal 0. So again, we're trying to find the y component. So it'll be m of the beam g plus m of the sine g when we take them across, minus ft, and the y component this time is the opposite side, so it's sine. Fill in your numbers. M of the beam was 3 kilograms, 9.81 meters per second squared, plus 9 kilograms, 9.81 meters per second squared, minus 206.01 newtons, sine of 30. All right, so I didn't find the other one. This is where I'm missing you all to do the math for me times, or confirm my math and the math in my head. So this one should be Fx should be 178.4099 newtons. And this one uh, 12 times 9.81 minus 103.005. This one should be 14.715 newtons. And usually the y component is always tinier because it's the x component that's important. The house is pushing out on the beam, because if it wasn't, then the tension would be pulling the beam in. And usually, though, it can't push straight out. It needs a tiny little component in the y direction. And what we're looking for, and the y direction works out to be positive, which means it is indeed going up. And so we're looking for this and this angle. So you're going to square them, add them together, and take the square root. And when you do, I think you get 179.016 newtons. And then you have to find the angle. So that, and what was it? 14.715. And I think you get a little tiny angle. So 179.016 newtons at an angle of 4.715 degrees, and it would be CCW beam. Okay, so that now finishes example 2. And the reason I wanted to do that is because it's like question number 33. Because question number 33 is a hanging light, and it has a tension going up here, Ft. The light fixture is hanging down here. The beam has a weight here, and of course the pole is also putting a force on. Okay, so it says the light fixture is 24 kilograms. And it says the beam is 3.5 kilograms. And it says this whole thing is 1.6 meters. And part A again, oh, and the angle is 33 degrees. And part A again, just like in the example, what is the tension? So sum of the torques equal to 0. A tension from the pole, or torque from the pole, that's going to go to 0. Tension, beam, light. Again, positives, negatives, counterclockwise, clockwise. So R tension, F tension, sine theta tension, minus R of the beam, FG of the beam, sine theta of the beam, minus R of the light, FG of the light, sine theta of the light equals 0. These two again are going to be 90, rearrange for tension. R of the beam, M of the beam, G, which is positive when you take it to the other side. R of the light, M of the light, G, also positive, divided by R tension, sine theta tension. So the beam's mass was 3.5 kilograms. Whoops, forgot the R. Uniform beam, 1.6, so it should be 0.5 meters, 9.81 meters per second squared, plus the beam itself was 1.6 and the light's out on the end. The mass of the light was 24 kilograms, 9.81 meters per second squared, tension 1.6 meters, and sine of 33. And when you do that, you should get an F of the light to be 463.81 newtons. Okay, assuming that I punched everything in there correctly. You're not here to tell me, but I think it is. Okay, and then you have to do the same thing to find this FP for part B. So sum of the forces in the X should equal 0. And then so it'll be FPX minus FTX equals 0. FPX will equal FT cos theta. So that 463.81 newtons, going to run out of time, cos of 33. PX equals, and then sum of the forces